So this problem says a box with a square base and open top must have a volume of 32,000 cubic centimeters. We wish to find the dimensions of the box that minimize the amount of material used. So the amount of material would be represented by surface area. To figure out how to minimize the surface area, let's first draw a picture of our box. So if we have a box, I like to start by drawing a square and then some little lines and connect it up. Okay, so here's our box. That's kind of small, but should work. If we call the base, because we know it's a square base, we can say that both the bottoms dimensions would be x and x. We don't know that the height of it is equal to the base though, so let's call the height of it y. And once we've labeled these, let's use our volume formula. We know that the volume of a box would be volume is equal to length times width times height. And we're given that our volume is 32,000, so we can say 32,000 is equal to, our length is x, our width is also x, and our height is y. And since we're trying to write our area formula as a function of x, let's solve for y as a function of x. So this would be 32,000 is equal to x squared y. Divide both sides by x squared. That gets us, if we divide both sides by x squared, we would cancel that out and give us y is equal to 32,000 divided by x squared. So that would be an expression for y in terms of x. Now we need to figure out an expression for the surface area. So surface area would be the area of each of my sides. Remember that my top of my box is open, so we don't have anything for that, but the bottom of the box would be x times x, which is x squared. And then if we have the front of the box would be x times y, so plus x times y. And then the left-hand side of the box would be x times y again. The right-hand side of the box would be x times y. And the back of the box would also be x times y. Okay, so we can simplify our surface area formula by, we have xy, 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 so that's 4xy's. It would be x squared plus 4xy. But we determined that our y is equal to 32,000 over x squared. So let's substitute 32,000 over x squared for y, which gives us a squared plus 4 times x times 32,000 over x squared. And now this x will cancel out with one of our x's in the denominator to leave us with 42,000 times 4 is equal to, 32,000 times 4 is equal to 128,000, and we would have one x left in the denominator. So let's write this as x squared plus 128,000 over x. That would be our area formula in terms of x, assuming that the x is the length of one of the sides of the base. Okay, so our next step is to find the derivative. The derivative of x squared would be 2x, and if we move this x to the numerator, that would be x to the negative 1. When we use the power rule to take the derivative, it would be our coefficient times -1, which would be -128,000 x to the power of -2. So that would be our a prime of x. We could move the x back to the denominator if we don't want to have a negative exponent left in our formula, but we don't necessarily have to simplify. Then it says, now find the x which minimizes surface area. So if we're minimizing surface area, we need to set the derivative equal to 0. Let's set 2x minus, I'll move the x squared to the bottom, 128,000 over x squared is equal to 0. So now let's move the negative term over to the other side to make 2x is equal to positive 128,000 over x squared. Now multiply both sides by x squared to make 2x cubed is equal to 128,000. Divide both sides by 2 to make x cubed is equal to 64,000. And then cube root both sides to get x is equal to 40. So 40 would be our critical point, which would be the value of x that minimizes the surface area. So we only have one critical point, so it must be the minimum. And what is the minimum area? So that's taking our critical point and plugging it back into the original area formula, not the derivative, but the original formula. So a of 40, a of 40 is equal to 40 squared plus 128,000 over 40, which is 40 squared is 1,600 plus 128,000 divided by 40, which is 4,800. So that would be our minimum area. And 4,800, because the volume was a cubic centimeter volume, we can assume that the area would be a centimeter squared unit, and the x value would also have a centimeters unit. So I don't know if they want you to include that or not, but just for completion. So I hope this step-by-step solution was helpful for you. If it was, please subscribe to my channel and click the notification bell so that you'll be notified when I make a new video. Thanks for watching.